Ever stop and think about what's actually happening when you plug in your phone or flip a light switch? Well, it's not magic, it's physics. And today, we're going to crack the code on the single most important rule that governs all of it, Ohm's law. Trust me, this simple idea is the key to understanding that whole invisible world of electricity.
I mean, think about it. Electricity is everywhere. It's literally powering our entire world. But what are the rules? How does this invisible force actually behave? Well, it turns out the answer lies in one simple, incredibly powerful principle that honestly changed everything.
So let's get right to it. What is Ohm's law? You could think of it as the fundamental rulebook for any electrical circuit. It tells us exactly how electricity is going to behave, and once you get this, everything else in electronics just starts to click into place.
At its heart, Ohm's law is all about the relationship between three key players: voltage, current, and resistance. You can see it right there. Voltage is the push, current is the flow, and resistance is what pushes back. These three are always in this kind of constant dance. And the real magic of this law is that if you know any two of them, you can always figure out the third. It takes all the guesswork out of electricity.
And here it is, the whole thing boiled down to one beautiful little equation: V equals I times R. Voltage equals current times resistance. Now, it looks simple, right? And it is. But don't let that fool you. This one formula is pretty much the bedrock of all modern electronics. So let's really break down what each of these letters actually means.
Okay, so let's look at the lineup. First up, we've got voltage. That's V, and we measure it in volts. Just think of this as the electrical pressure that's all built up, ready to push those electrons through a wire. Then you've got current, represented by I, which we measure in amps. This is the actual flow, like how many electrons are zipping past a certain point every second. And last but not least, we have resistance, or R, measured in, you guessed it, ohms. This is anything in the circuit that's trying to slow that current down.
Now, I know these ideas can feel a little abstract. You can't actually see voltage, can you? So to make this all feel way more intuitive, we're going to use one of the best analogies in all of physics: the water pipe system.
So just picture a simple system of water pipes, okay? In this scenario, the voltage is just like the water pressure. It's the force that's pushing the water along. The current, well, that's the actual amount of water flowing through the pipe. And the resistance, that's all about the pipe itself, specifically how narrow or wide it is. And this is where it all makes sense. A really narrow pipe creates high resistance, right? So even with a lot of pressure, you're only going to get a little trickle of water. But if you have a big wide pipe, that's low resistance. That same amount of pressure can create a huge fast flow. This is exactly how electrical resistance works to control the flow of current. See? It's really that simple.
All right, analogies are awesome for getting the why, but the real power of Ohm's law is in figuring out the how much. So let's put this thing to work and see how we can use that formula to make some real calculations.
Okay, here's our setup. Super simple. We've got a standard 9-volt battery. That's our pressure, our voltage, and we've connected it to a little component that has 3 ohms of resistance. So the big question is, how much current, how much flow are we actually going to get through this thing? So how do we figure this out? Well, first we always start with our base formula. V equals I times R. But we're looking for the current, I. So with a little bit of simple algebra, we just rearrange it. Current I equals voltage divided by resistance. Now for the easy part, we just plug in the numbers we know. 9 volts divided by 3 ohms.
And the answer is 3. But 3 what, right? You always need the unit. It's 3 amps. We just figured out that exactly 3 amps of current are flowing through that circuit. Just like that, with one simple formula, we've gone from guessing to knowing. That's the power of Ohm's law.
Okay, we've moved pretty fast, I know. So let's just take a second and boil all of this down to the absolute essentials you need to remember.
So what are the big takeaways? First, just remember that core relationship. Voltage, current, and resistance are always linked. Second, if you ever get stuck, just go back to that water pipe analogy. It makes everything so much easier to visualize. Third, your units are your best friends here. Always think in volts, amps, and ohms. And finally, and this is the big one, you now have the fundamental tool you need to analyze any simple circuit. Seriously, this isn't just some formula, it's your first real step into the world of electronics.
So there you have it, Ohm's law. It's the simple, elegant rule that governs all that invisible energy powering our lives. You've just cracked a fundamental piece of the code. So the only question left is, what are you going to understand next?